Hello everyone, thank you for joining this presentation. So in the previous presentation, you had more general principles and some examples of using automated material discovery. In this talk, we will discuss accelerated discovery through informatics and AI with a specific focus on battery materials. I'm delighted to say that the presenter is Professor Anssi Laukkanen. I hope I pronounced the family name right. He's a professor at VTT in the Computational Materials and Data Sciences group. The presentation will be 15 minutes. 2 minutes before the end of your talk, Anssi, I will intervene just to let you know you have 2 minutes left. Apart from that, yeah, the stage is yours.
Okay, thank you for the kind introductions and for the opportunity to keep this talk. So this is going to be more. This is going to be essentially what you would do in talk, focusing on what you would do with AI materials and overall in the domain of battery materials. And first off, the kind of like 30-second of why should anyone care about this topic. Of course, in terms of the material domain of interest, in terms of battery materials, energy storage materials, or energy harvesting materials, or anything to that effect, let alone material research, there's of course quite a bit of drive to push these areas forwards overall. But the sort of question that what would be our specific interest in terms of utilizing and being caring about AI applications in this domain is kind of really briefly in this one slide. And overall, we can kind of say that there are a couple of really quick, swift, and rather comprehensive arguments that you can make in terms of why should we embrace essentially the AI paradigms in terms of battery materials and overall in terms of materials research. And we, first and foremost, we can kind of acknowledge that whether we're interested in something rather general or something rather specific in terms of just tackling materials problems, we have a rather wide scope in that sense. We can kind of address with the respective methods, as you will see in the following slides. So whether we're kind of going through the kind of rail in that sense that we want to discover new materials or come up with new material ideas, evolve existing materials, or, for example, optimize how well our material operates in a certain specific material solutions, or then develop synthesis processes, or simply that simplest form of problem where you essentially try to tackle some materials problems. Uh, we can more or less to all of these, we can find some interesting new ways and aspects in the utilization of AI, which kind of goes, of course, goes beyond the hype of just applying AI to new problems and expecting some better return. But the kind of reasoning, for example, for why VTT is kind of involved in this and why we kind of approach this, as you see in the following slides, is that we, of course, all know that one of the most dreaded problems associated with any kind of development in materials or products where materials emphasis is heavy, and one of the big problems there is, of course, that traditional ways of going about this are rather inefficient, to be honest. So if you try to push forwards with any sort of greater material innovation, I mean, you're talking about years. And typically, when something is years, it then of course also means that it's rather costly, and that's of course a bit of a problem. And of course, we can kind of argue that nowadays everyone is doing something in the modeling and simulation realm, and it's not years anymore. And we, for example, at VTT, we talk a lot about how to integrate experimental characterization, synthesis, modeling, and AI techniques in a smart enough manner, so kind of like digitalize the materials field. And you can, for example, pick some of the, or let's say the buzzwords of the last 5, 10 years, like ICME, in terms of the materials domain. And we can kind of argue that, well, we can get quite a bit done if we embrace everything we have on the modeling and simulation frame within, say, a time frame of a year. So essentially tackling these classical from processing to performance problems with ICME. And that's already a rather big improvement. But then the area where AI especially comes into play is that traditional ICME rather looks this as a forward problem. So